Hey guys, myself Akhil Vardhan Reddy, and this is batch 3 from AMLB CSM department, and my group members are Sathwik Reddy and Narander. So, our project is image forgery detection based on fusion of lightweight deep learning models. Basically, we'll be dealing with the image operations as the image forgery in the sense we'll be comparing original image and the fake image. If there any difference between those two images, we can identify that the image is forged. So before diving into the implementation of our project, let's go into the outlet of our project. So let's go into the architecture. So first we'll be knowing that the data sets. So I will be giving input for our project. We'll be giving images as an input for a project as we are dealing with the image project, and have taken the two types of images. One is original image and one more is forged image. So I'll be giving these two types of image folders to my project. First step, I'll be doing the data pre-processing. In data pre-processing will be first we'll be normalizing the resolutions of every image, because the forged image may have higher resolution or lower resolution, so there should not be a factor which can affect my accuracy. So to overcome this principle, I'll be normalizing all the resolutions of every image, in fact original image also. I'll be neutralizing all the resolutions of original as well as the tampered images first. Second, in data pre-processing, we'll be resizing the image size. So because the tampered image may have different size on compare with the original image. So we'll be first resizing both the images correctly, so that that can easily we can identify the correct or fake image easily. So this is the two things will be going in the data pre-processing. Next, we'll be looking into the training of our models, training our algorithm. We'll be taking the three algorithms. First, we'll be going to the MobileNet V2. MobileNet V2 indicates the version 2 of MobileNet. MobileNet is an algorithm, that is a deep learning algorithm. So it mainly works. I have taken this algorithm basically in the point of mobile users, because when we compare with the mobile working performance or else any software with the laptops and PC, mobile device have the less performance. So our algorithm should not stick only with the laptops or PCs or higher devices. It should can be implemented in the low devices like mobile also. So I've taken in the point of mobile users. I've take implemented this type of algorithm which can implement in the mobile device also, because mobile net will be using less resources in the sense memory storages, because mobiles have less storage when we compare to higher device, right? So it need to compare with the devices. So I've taken the mobile net which can be suitable for a project. Next to ShuffleNet. ShuffleNet mainly divides the project into several divisions. Then by using iterative method traveling, it travels through the whole the division and compare with the tampered one. So if we found any change in any division, then the focusly does it travels to all the pixels in the division. Will be comparing to the other images. If we found any change, then we will be easily identifying this is the forged image. So by traveling only that division, it can easily identify. It does not need to travel whole divisions. By this, it can save the time. Time complexity will be decreased. But let's go for the uh, Usenet. This mainly deals with the traveling pixel by pixel. So it travels pixel by pixel and compare with the two images, nothing but original. So it covers from start to end of an image. So we'll be traveling by using the for loop in our code. So these are the three algorithms we'll be using in our project. Next, the result which we get from our project will be mapping, right? Will be mapping. we can see that the three separate will be using for the mapping of those outputs. Yellow and brown will be easily identifying these things. And next, SVM is the classifier, that is the machine learning algorithm. So, what is the need of using of SVM? So, we'll be using SVM to get the output forged or not. That is the main thing, right? We'll be looking into the same, like whether our project is working with the correctly. So, let's for an assumption, let's take the first two algorithms will be giving the two outputs are the forged one, but the last algorithm will be giving that is a not forged. So SVM will be works on the these two, which are the probability, which take the probability of forged one, and it will be storing nothing but mapping, then we'll be getting the output of forged. So this may be quite confusing. Let's go into implementing of things so that you can easily understand how it works. These are the four algorithms we'll be using in our project. So let's go into the running or implementation of our project. Before implementing, we'll be looking the data sets. So I've mentioned it before that the two types of data sets I've taken folders. One is the original and one more is a tampered. So in original image, I've inserted all the original images which are related to our project. So just uh, assume this is the original image. So we'll be comparing with the tampered image, which are similar to this thing. How it can be identified? So it can, as you are telling that we'll be traveling pixel by pixel, you can easily identify this is the image which are related to compare. Example, you can see these are the related images for this. So let's take this image sample. Consider the extra part in which differ from the original image. So by our naked eye, we can easily identify that this is the extra part. But there will be minute changes in the images which cannot be identified by our naked eye. This can be identified by our algorithms. So these are the two data sets we'll be using, and let's these are the this is the fusion mode. uh, will be all the code will be have set in tier. I will be showing the code also. So tk enter for the user interface, and matplotlib for the getting the matrical format, like in graphical format of output, and field log will be using for the inserting the data sets for the getting. For these are the scikit-learn. These are the machine learning algorithms models of the Python. So these are the basic models which you're going to using. What is the outlet of for my code? Let's implement my code. So you can implement this code in the command prompt. Is you can type the Python space the name you have given for your folder dot py extension. So same thing. Then you can click enter. You can see the output. So yeah. First thing you can see in this button, first button, you mentioned that upload datasets. So let's upload the datasets. After clicking on the first button, you will be redirecting into the file managers, and click on the datasets and click select folder. You can see in the message box the datasets are loaded, right? Now let's go into the pre-processing datasets. I mentioned in pre-processing two things. Okay. In worst case, we'll be taking the less resolution. I have changed all the pixels to less resolution, and you can see the gap between this. This will be indicating the uh, resizing of image. So this is a sample image I have shown to you, and you consider the 220 images in my datasets. Next step will be training our algorithm by using the datasets. By clicking the generate fine tune fusion model, we can train our algorithm. So these are the three algorithms, and these are their accuracy, F1 score, recall score, accuracy score. So here the main thing is 576 features will be extracting from these three algorithms, right? So by using these features, we'll be training our SVM model, nothing but classifier support vector machine algorithm. See, after clicking on run support fine tune feature, we'll be getting the output of this. SVM prediction 98%, 97%, 97% F4 recall accuracy. So I've used a math plotly, we'll be using here. After forged, we'll be getting 25 forged, that's the correct one. But for non-forged, they'll be getting one extra non-forged thing. It is fake. This is wrongly assumption. For this, we'll be getting now 98% of accuracy. 97. So these are the basic outlet of a project. Now let's insert a single image and let's see whether it's working with the single image correctly or not. After clicking on the upload image, will be redirect in the file manager. Then data sets we need to. In this case, okay, we'll be taking the tamper images, and I have selected one random image. Now I click on the open. Will be know that the this is image is forged output in the message box. Okay, let's upload the original image. Will be see original image. Randomly I've selected this thing. You can say that the upload image is not forged, right? So in this box, so let's extract the performance matrix. So this is the performance matrix. All the performance are above 75%, which is good to hear. So I've given an exit button where the user can easily get out of this interface. After clicking, you can easily exit from it, right? That's it. The project is very simple. Thank you. Thank you.